You know, in the world of architecture and construction, a project's success, it's built on a mountain of data, millions and millions of data points. But what happens when that data starts to, well, lie to you? Today we're going to dig into how one tiny, almost invisible error can spiral into a massive failure. And more importantly, we're going to uncover the one simple rule that can stop it in its tracks. Take a look at this number, 0.05 square meters. I mean, it's tiny, right? It's smaller than a single floor tile. You'd think, who cares? But believe it or not, an error this small can be the one thing that separates a successful project from a nightmare of a legal battle. So, what's the real cost of a mistake this tiny? And that, right there, is the heart of the matter. Is it just a simple rounding error, or is it something much, much bigger? A critical liability? We're basically going to put this little number on trial and see exactly how a simple mismatch on a drawing can blow up into a huge professional risk for an entire company.
All right, so here's our game plan. First up, we'll start with a tale of two numbers to see this problem up close. Then we'll dissect exactly how these errors happen. After that, we'll get to the good stuff, the golden rule of data. I'll even give you a practical playbook to put it all into action. And finally, we'll see how to go from risky redundancy to rock-solid reliability.
Okay, let's dive into our first section, a tale of two numbers. And here's the crazy part. The problem we're talking about, it isn't buried in some complex code or hidden away. Nope, it's usually sitting right there in plain sight on the project drawings.
And here it is, Exhibit A, if you will. On one sheet, the summary, it says the office area is 485.38 square meters. Okay, but then you look at the detailed calculation sheet, the actual source, and it says 485.33. Now, they're both official documents. So which one's right? If you're the contractor or the client or even the city, you have absolutely no idea which number to trust. There's a name for this. It's called data divergence. And listen, this is the key takeaway. This problem isn't just possible, it's inevitable. The second you manually type a value into a second location, you've just planted a time bomb. It is not a question of if these two numbers will conflict, it's only a matter of when. You know, it's so tempting to think that repeating important info is like a safety net, right? Let's put it in a few places so no one misses it. But in the world of professional documentation, that thinking is just wrong. It's completely backward. Every time you copy and paste that data, you're not creating a backup. What you're actually doing is setting a trap, a liability trap that someone on your team is guaranteed to fall into.
Okay, on to section 2, the anatomy of an error. So how does this actually happen? Well, it's almost never because someone's lazy or bad at their job. The real culprit is a flaw in the system itself, in the workflow. It's a classic case of good intentions paving the road to, well, bad data.
This flaw has a name, update asymmetry. And the idea is actually super simple. Think about it. A design changes. So the main live document gets updated. But that summary table you manually typed out on another sheet, it gets forgotten. It's just human nature. We focus on the source, not the copies.
Let's just walk through how this data rot sets in, step by step. 1. A design change is made. A wall moves. A room gets a little bigger. Whatever. 2. The designer updates the main source document, the calculation sheet. 3. Here's the crucial mistake, the lag. They totally forget to go update that summary table on the cover sheet. And boom, step 4. The summary sheet is now officially lying about the project details.
And look, this isn't just my opinion. The global consensus here is crystal clear. Big international standards, like ISO, they basically forbid this. Legal experts, they warn you against it. Modern software, like BIM, it's literally designed to prevent you from doing this. In fact, manually typing over a value in a BIM model is what they call breaking the model. The message is coming from everywhere. Redundancy is risk. Period.
All right, section 3, the golden rule of data. So, we've picked apart the problem, we've seen how dangerous it is, but the good news, the solution is incredibly powerful and honestly, it's surprisingly simple. It all comes down to a whole new way of thinking about how we handle information. And here it is, the golden rule. You might want to write this down. Define once, reference everywhere. That's it. It means that every single piece of data gets to have one and only one home, one single source of truth. Everywhere else you need that data,
You don't copy it. You just point to it. You reference it.
So what this really boils down to is understanding the difference between a primary and a secondary source. The primary source is where the data is actually born, right? It's the calculation sheet, the detailed model. The secondary source, like a summary table on a cover sheet, should just be a window looking at that data. It should never, ever hold its own version of the data. It only points back to the original.
Okay, section 4. Let's talk about your SSOT playbook. Because theory is great, but how do you actually make this single source of truth thing happen on a real project? Let's get super practical with a playbook you can start using, like, tomorrow.
So let's look at the wrong way versus the right way to make, say, a summary table. The wrong way is what we call hard coding. That's just manually typing a number into a cell. That data is now dead. It's static. The correct way is referencing. Instead of typing the number, the cell just contains a little pointer, something simple that says, hey, for this number, go look at sheet A502. That way, the data is always alive, always connected back to the source.
Now, how do you police this? Your QA/QC team can use a super simple checklist. First is the data echo check. You find a number in a summary, then you hunt down its source. Do they match exactly? If not, that's a big fail. Second is the orphan text check. Look at a key number on a drawing. Is it just dumb static text, or is it a smart field that's actively pulling that data from the source? Any number that's just plain text should be a huge red flag.
And the best part is, you can build this discipline right into your software. It doesn't matter if you're using AutoCAD or a fancy BIM platform like Revit or arcICAD. The principle is exactly the same. Use the tools the software gives you for referencing, for creating fields and calculated values. Just please never use a plain old text box for something as critical as an area number. Let the software do the heavy lifting for you.
And that brings us to our final section, from redundancy to reliability. See, when you really adopt this mindset, you're not just fixing a few typos. You are fundamentally changing your entire workflow, from something that's brittle and full of risk to something that is truly robust and reliable.
Just look at this transformation. On the left, you've got our original problem, two numbers basically at war with each other. On the right, you have this beautiful, simple solution. Instead of trying to force the numbers to match, you just get rid of the second number entirely. The summary sheet just says, hey, for this info, go see the source. It's so simple, it's honest, and it's completely foolproof. And you know, at the end of the day, this isn't just about avoiding lawsuits. Though, yeah, that's a pretty big plus. The real goal here is to build systems of trust. It's about creating project documents that aren't a ticking time bomb, but a genuinely trustworthy asset that adds real value to your project and, frankly, to your reputation.
So I'll leave you with this one last really crucial question. Take a hard, honest look at your own projects, your own processes. Is your documentation a reliable asset that you can stand behind, no questions asked? Or is it a liability trap, just waiting for one tiny little number to spring it shut?